Today we're going to review for your Unit 2 test, which will be given Monday. You should be on page 32 of your notes packet. The first part of this is looking at the likelihood of events. Number 1 says, in a shipment of t-shirts, half are gray, 1/5 are white, and 3/10 are green. If K randomly chooses a have either mushroom or pepperoni as toppings. Jerry randomly chooses slices and places them on plates. The first plate has 3 slices of pepperoni and 2 slices of mushroom. The second plate has 2 slices of mushroom and pepperoni, and M slices of mushroom. If the probability of drawing a pepperoni slice from each plate is 6/25, how many mushroom slices are on the second plate? So I don't know how many mushroom there are, but I know that my first plate has 3 pepperoni and 2 mushroom. And I know that my second plate has 2 pepperoni and I don't know how many mushroom. I know that the probability of them together is 6/25. Well, if I'm finding compound probability, then I know I need to multiply this probability times this probability. Well, my first probability of pepperoni is that there are 3 pepperoni out of 5 total slices because there are 5 total slices on this plate. On my next plate, I know that there are 2 pepperoni out of I don't know how many slices. I know that when I multiply these together, I get a compound probability of 6/25. Well, 3 times 2 is 6, so this works. So 5 times what is 25? Well, I know that this is actually 5 because 5 times 5 is 25. Now, 5 is not the number of mushroom slices. 5 is the total number of slices that are on this plate. Since I already have 2 slices that are pepperoni, then I need to have 5 total slices. Well, then 3 of them are going to be mushroom. So I would say that there are 3 mushroom slices of pizza on the second plate. Number 6 says Harris rolls a number cube and flips a coin. What is the theoretical probability that the coin lands on heads and you roll a number greater than 4? Write your answer as a fraction, decimal, and percent. Well, the first thing I would need to do here is find the probability of landing on heads. Well, I know that there is 1 heads out of 2 sides on my coin. Then I need to find the probability of rolling a number greater than 4 on a number cube. Well, if I think about a number cube, the numbers that are greater than 4 are 5 and 6. So that is 2 numbers greater than 4 out of 6 total numbers. Well, 2/6 simplifies to 1/3. So if I'm going to find this probability, then I'm going to do the probability of heads followed by a number greater than 4, and I'm going to multiply them. So I'm going to multiply 1/2 times 1/3. Well, 1 times 1 is 1, and 2 times 3 is 6. So this compound probability is 1/6. Number 7 says Margaret is choosing from a lunch menu. The chart shows her options. We want to create a tree diagram that shows the options she has if she can choose 1 sandwich, 1 side item, and 1 dessert. And then we're going to write out the sample space. Well, the first thing we have are our sandwiches. She can choose from a chicken salad sandwich or a ham and Swiss sandwich. From here, she can choose either chips, pasta salad, or fruit salad. So from each one of these, she has 3 options: chips, pasta salad, or fruit salad. Then she can choose a dessert of a cookie or a brownie. Well, if she chooses chicken salad and chips, she could do a cookie or a brownie. If she chose chicken salad and pasta salad, she could still do a cookie or a brownie. If she chose chicken salad and fruit salad, she could still do a cookie or a brownie. If she chose ham and Swiss and then chips, she could do cookie and brownie again. Pasta salad, she could do cookie and brownie, and fruit salad, she could do cookie and brownie. If I wrote out this sample space, then I would have chicken salad, chips, and cookie, chicken salad, chips, and brownie, chicken salad, pasta salad, and cookie, chicken salad, pasta salad, and brownie, chicken salad, fruit salad, and cookie, chicken salad, fruit salad, and brownie. Then I would have my ham and Swiss. So I could have ham and Swiss and chips and a cookie, ham and Swiss and chips and a brownie, ham and Swiss and pasta salad and chips, ham and Swiss and pasta salad and a brownie, ham and Swiss and fruit salad and chips, ham and Swiss and fruit salad and a brownie. So when I look at my outcomes, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total outcomes in my sample space. Now I can use my tree diagram to find these probabilities. I want to know the probability that Margaret will choose a chicken salad sandwich, pasta salad, and a cookie. Well, when I look at all my chicken salad, the only time that she chooses pasta salad are on these two options. But then the only time she chooses a cookie is right here. So there is only one outcome where she chooses pasta salad, chicken salad, and a cookie out of 12 total outcomes. Next, it says, what is the probability that Margaret will choose a lunch that contains fruit salad? Well, when I look at my options, she chooses fruit salad twice with chicken salad and twice with ham and Swiss. So altogether, she chooses fruit salad 4 times out of 12. And that simplifies to 1/3. Now I want you to go to page 34. Number 8 says Sarah is packing for a week-long trip and is packing 7 pairs of pants. 4 are jeans, 2 are black, and 1 is khaki. Sarah does not plan on wearing a pair of pants more than once. The first problem says, what is the probability that Sarah will wear jeans on the first day? Well, if there are 4 pairs of jeans and 7 total pairs of pants, then the probability of her wearing jeans is 4 pairs of jeans out of 7. Then it asks, what is the probability that Sarah will wear jeans on the first day and black pants on the second day? Well, we would need to look at each of these probabilities. So the probability of jeans on the first day was 4/7. But the probability of black pants on the second day is that there are 2 black pairs of pants. But since she would have worn a pair of jeans on the first day, and we know that she does not plan on wearing a pair of pants more than once, then now there are no longer 7 pairs of pants to choose from. Now there are only 6 pairs. Well, 2/6 can simplify to 1/3. So the probability of jeans followed by black pants is 4/7 times 1/3. 4 times 1 is 4, and 7 times 3 is 21. And since that cannot be simplified, that is our probability. Number 9 says Crystal has a bag that contains 1 red, 1 yellow, and 1 blue marble. She has another bag that contains 1 orange, 1 green, 1 purple, and 1 pink marble. We want to show the sample space of all of the possible outcomes if she chooses 1 marble from each bag. Well, if she chooses red from the first bag, she could choose orange, green, purple, or pink from the second bag. If she chooses yellow from the first bag, she could choose orange, green, purple, or pink from the second bag. And if she chooses blue from the first bag, she could choose orange, green, purple, or pink from the second bag. So when I look, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total outcomes in this sample space. What is the probability that Crystal will select a yellow marble from the first bag and a pink marble from the second bag? Well, I need to find the probability of each. So the probability of yellow is that there is 1 yellow in the first bag out of 3, and the probability of pink is that there is 1 pink marble out of 4 in the second bag. Well, I could do 1/3 times 1/4, and 1 times 1 is 1, 3 times 4 is 12. I also could have just used this list that I wrote out. If I'm looking for yellow and pink, that only happens in this one spot. None of the other options include yellow and pink. So that is 1 out of 12 outcomes. The next one says if Crystal combines all of the marbles into one bag, so now instead of 2 bags, we have 1 bag, and that has red, yellow, blue, orange, green, purple, and pink. What is the probability of her choosing a yellow marble followed by a pink marble, this time without replacement? Well, now the probability of yellow is no longer 1/3 because now there is 1 yellow out of 7 marbles. Then, because we are not replacing it, there is now 1 yellow taken away. So now we're looking for pink. There's only 1 pink, but this time there are only 6 marbles. So the probability of yellow, then pink, is going to be 1/7 times 1/6. 1 times 1 is 1, and 7 times 6 is 42. So this probability is 1 over 42. Now let's look at our last problem. We have a table that shows the results of 2 experiments. And we want to know the probability of choosing a black marble in the first experiment and a green marble in the second experiment. Well, let's look at this. So the probability of black in our first experiment is that it occurs 1, 2, 3, 4 times out of 10. Well, 4/10 will simplify to 2/5. Then we want to look at the probability of choosing green in the second experiment. Well, when I look here, that occurs 1, 2 times out of 10, and 2/10 simplifies to 1/5. So the probability of black, then green, is going to be 2/5 times 1/5. 2 times 1 is 2, and 5 times 5 is 25. So this probability is 2/25. Then it asks, what is the probability of choosing a white marble in both experiments? Well, let's find the probability of white in each one. So in our first experiment, white occurs 1, 2 times. So that is 2 times out of 10, and 2/10 simplifies to 1/5. In our second experiment, white occurs 1, 2, 3, 4 times. So that is 4 times out of 10. 4/10 simplifies to 2/5. So the probability of white followed by white is going to be 1/5 times 2/5. 1 times 2 is 2, and 5 times 5 is 25. So this is a probability of 2/25.